Alright, so here we have a thrust system that we are going to determine if it is statically determinate. So as you can see, our equation to solve this is 2 times J equals M plus R, with J standing for the amount of joints that we have, M standing for the amount of members we have, and R standing for the reaction forces that we have. So since we have 4 joints, we're going to multiply this by 4. We have 5 members, which are the lines. And then since pin connections have 2 reaction forces, we have to times that by 2, which gets us 4. And then when we get this all together, we see that it is not statically determinate, so that means we have to draw a newer one that is statically determinate. So here we have redrawn our thrust system. As you can see, I replaced one of the pin connections with a roller connection because that's only one reaction force. So now when we write the equation, we still have the same 4 and 5 from the previous equation, but now since this is only 2 and this is 1, right there, sorry, we get 3, and then when you add that all together, you get 8 equals 8, which means it is statically determinate. Okay, so step 2 is to replace the supports with reaction forces. So since we had a pin and roller connection, for the pin support, we would have RDX and RDY, and then for the roller connection, we would have RCY. Just also mentioning that we labeled our joints with A, B, C, and D, and this thrust is going to be 2 feet on all sides because it is a square. Okay, so for step 3, we have to use the moments to find our CY. And in order to do that, we have to use our 2 equations. Our first one is going to be the sum of the moments, which equals 0. But in order to find these moments, we have to use the moment equation, which is the force times perpendicular distance. So as you can see, we're going to use joint D since it has the most unknowns. But since we aren't able to find the moments from there, we're just going to use all the other ones. So we have moment here, which is moment A. Since there is not a force that's acting on it, we just have to make the moment of joint A equal to 0 because there's nothing acting on it. Then for joint B, we have a negative 100 pounds since it's going down. And then times it by 2 because its perpendicular distance is 2 feet, which equals negative 200. Then we have moment C, which is the force that's acting on it is RCY. Then we have its perpendicular distance of 2 feet, which just equals 2 times RCY. Now we can add all these moments up together using the sum of the moments equation. Equals 0. So as you can see, we could just get rid of this because it's obviously 0. So now all we have is negative 200 plus 2 times RCY, which equals 0. We could add the 200 on both sides. Now all we have on this side is 2 times RCY, which equals 200. Then we divide both sides by 2 to get RCY by itself. And RCY equals 100 pounds.
Okay, so the next step, step 4, is using the sum of forces in the x direction to find RDX, which is this one. And we're finding the forces in the x-axis, which would be across here. And the only force we have going in the x-axis is RDX. So we would set RDX equal to 0. And since that's the only force in the x-axis, that's it, making it 0 pounds. 1. Okay, so the next step, step 5, is using the sum of the forces in the y direction to find RDY, which is this one. So you're going to take all your forces in the y, which is the 100 pounds going down, which makes it negative 100 pounds. And then your next force, you can just take this one, which is RCY, and it's positive because the arrow is going up. So it's RCY. And then the last one that's going in the y direction is RDY, which is also positive because it's going up. And you set that all equal to 0, because that's the equation, which is sum of the forces in the y direction is equal to 0. And then what you're going to do is you're going to replace the things you already know. So for example, you already know RCY is 100 pounds. So you would replace that with 100 pounds. And you just carry down the negative 100. And you bring the RDY down. And you set that equal to 0. And the negative 100 pounds and the 100 pounds cancel out. Okay, and since those cancel out, the only thing you're left with is RDY is equal to 0, and that's your RDY.
Okay, and then for step 6, for 6A, we need to use the thrust dimensions to find the angles. Now, since it's a square, you don't need to do both of them because it's a square, so they're obviously the same. And we know that this is a 90 degree, and then we have two unknown angles, or thetas. So, since we have this is the adjacent for beta C, and then this is the opposite, we can use tangent. So for tangent, it's obviously opposite over adjacent for SOHCAHTOA. So it would be tangent theta C is equal to opposite over adjacent. And if we plug our numbers in, it's tangent theta C is equal to 2 over 2. Because obviously our dimensions are 2 feet. Now, since we don't know the angle, this will end up becoming inverse tangent, or tangent -1, times 2 over 2, which is equal to 1. 2 over 2 is equal to theta C. And if you do this in your calculator, you will get theta C is equal to 45 degrees. Now we know that a triangle is 180 degrees, so since we have 45, we can just do theta A plus 90 degrees plus 45 degrees equals 180. Now, once you add these together and you move it over, you'll get theta A is also equal to 45 degrees, because it's a 90, 45, 45 triangle.
Okay, so step 6B is draw a free body diagram of each pin. So you're going to draw your square again with A, B, C, and D. And it's usually better if you draw all your arrows in tension, which makes it easier to do the math. So you draw an arrow here like this, and like this, which becomes AD. An arrow here like this, and like this, which is AB. Arrows here, which is BC. Arrows here, which is DC, and then you also do the one across, which is AC. And then you also want to include the forces. So negative 100 pounds going, well, 100 pounds going down. Your RCY, which we figured out was 100 pounds in the previous step. So 100 pounds going up. And you can just write equals to RC to make it easier. RCY. And then you want to include these two, but you want to write RDY equals 0, and then going up, and then in your X direction, which is RDX equals 0.
Okay, so now for step 6C, you have to solve for the numbered forces, which is like all the joints. And we chose to do joint D because it has the least unknowns, but only has 2. You can also do joint B because it has 2 unknowns, but obviously we just did D because we also want to know what these 2 are. So we just figured it'd be easier. But to start this, we have to use our equation of sum of the forces in the y direction is equal to 0. So for y, we have RDY and then we have AD. So your equation would be 0 is equal to AD plus 0. So obviously, this just, you don't really have to do much, just kind of move it. So then AD is equal to 0. And then you want to do your y direction. So this is 0 pounds, and then this is 0 pounds. So then for your y direction, it's kind of the same thing. It's sum of the forces in the x direction is equal to 0. So then you do 0, and obviously our forces are rdx is 0, and then dc. So it's equal to dc plus 0. And then again, these kind of cancel out. So then dc is equal to 0 pounds.
Okay, so now that we solved for joint D, we can solve for joint B. Let's just draw our free body diagram with all the forces. So here is joint B. We have a force of BC right there, as well as the force from AB there. And we also have our 100-pound force acting on as well. So now we're going to solve for BC, and by doing that, we're going to use the sum of all the forces in the y direction equation. So first we have the 100 pounds that's going down, so which means it'll be negative. And we have BC that's going in the y direction, and since it's going down, it will also be negative. And that all equals to 0. We can take this 100 and add it to both sides. And then in order to get rid of this negative from the BC, we'll just divide it off from both sides. And there you go, BC equals negative 100 pounds. Hold on. And then now we're also going to solve for the sum of the forces in the x direction. So we're going to take our equation, which is this, and then since the only force that's being acted upon in the x direction is AB, we're just going to have AB equals 0 pounds.
Now that we have both of our equations to find ACY and ACX, we can use this equation, sum of the forces in the y direction is equal to 0, to find the rest of our values to get AC. So, we know that obviously ACY is in the y direction, and we also know that BC, which is a negative because it's going down, is also in the y direction. And then our CY, which is a positive because it's going up, is also in the y direction. So if we sub in all our numbers, it'll become 0 is equal to AC times sine 45 plus negative 100 plus 100. By this equation, we can already cancel out these two because they just subtract each other. So now we just need to find our AC. If we just divide both sides by sine 45, we will get that AC is equal to 0. And since we know what AC is, we won't need to use ACX because we already have this answer. So we can update our force body diagram to say that AC is equal to 0 pounds. And now we're done.